All right, hello folks. This is, we're starting with example 3. We're on 4-2 notes. We did some calculator stuff just a bit ago, so I can do that with you when you guys come back. But who are we missing? Carter and Ellie and Aubrey and... Am I sending this to Josie too?
Yeah.
Okay. All right, so those people. All right, there we go. Example 3, evaluate the 6 trig functions of the real number t. On your unit circle, find me pi. Where is pi located on your unit circle?
Right there.
Right there. He is 180 degrees, yeah? That's what pi is. Okay, give me the coordinate point for pi, or 180 degrees.
-1, 0.
-1, 0, right? Like on your unit circle, pi lives here, and that is -1, 0, yeah? Okay, they want us to find the 6 trig functions, so that means we start with sine. Sine of t equals cosine of t equals tangent of t equals. Which one goes with sine?
Cosecant.
Cosecant. The c's and the s's go together, so cosecant t. What goes with cosine?
Secant.
Secant of t, and then tangent is cotangent of t. It's like cot-ta-ta with 2 t's. All right, sine. The x-coordinate's -1, the y-coordinate is 0. We just pulled that off of the unit circle. But sine is which one? 0. Sine is the y-coordinate. Okay, so sine of t is 0. If we're looking at t being pi, sine is going to be 0. What's cosine? -1. This is cosine, this is sine. Okay, tangent. To do tangent, we do sine divided by cosine. 0 divided by -1. What does that come out to be? 0. It's not undefined, it's just 0. Okay? All right, cosecant is the opposite of sine, right? Okay, hold up. 0 as a fraction is what? 0 over 1, right? Now if I flip it, it will be 1 over 0. So what's the opposite of 0 over 1? Undefined, right? Do you see how that works? Cosecant will be undefined, okay? Secant goes with cosine. If I take -1 as a fraction, he's -1 over 1. Now flip it. What does he become? -1 again, right? -1 over 1 flipped is -1. Cotangent is the opposite of 0 again. What's the opposite of 0? Or the reciprocal of 0? Undefined. Okay? The reciprocal of undefined is 0. The reciprocal of 0 is undefined. Got it? They flip-flop with each other.
I don't like this.
I am sorry. Okay? All right. B. 5 pi over 2. Find him on your unit circle. Where? Ooh, do we have a 5 pi over 2? We definitely do, but he's not listed as 5 pi over 2 on your unit circle. Check out why. Your unit circle goes from 0 to 2 pi. 2 pi is the largest he goes, but what's 5 over 2?
2.5.
This is 2.5 pi, right? Right? So if I subtract 2 pi from 2.5 pi, I get a half a pi. What's 0.5 pi? What do they call it? They call it pi over 2, right? So 90 degrees. So we're looking at 90 degrees because that is the same as 5 pi over 2. What's that called again? What's 5 pi over 2 in relationship to pi over 2? Coterminal, right? So if we cannot find one that is, like, we cannot find 5 pi over 2, we do the coterminal angle to him, which is just pi over 2. Okay, pi over 2. Let's list the coordinates for pi over 2. It is 0, 1, yeah? Okay, 0 is which one, sine or cosine?
Cosine.
Cosine comes first, and then 1 is sine. Okay, so if I'm doing sine of t, cosine of t, tangent of t, we've got cosecant of t, secant of t, and cotangent of t. Okay, we've got all those guys. We just said sine was 1, cosine was 0. Cool. All right, tangent is sine divided by cosine. So what will tangent look like?
Undefined.
1 over 0. So, yep, undefined. Okay? All right, what's the opposite of, what's the reciprocal of 1?
1.
Like 1 over 1, the reciprocal of that is still just 1. What's the reciprocal of 0? Undefined. What's the reciprocal of undefined? 0. You see how that works out? Okay? do the first 3 from the unit circle, and then whatever, right? You could have pulled tangent off of your unit circle. Pi over 2 is tangent undefined. Pi over 2 on your unit circle. You can get him from the unit circle as well, right? Okay, good? Yes? We're just kind of like feeling for what the unit circle is and how to read it, yeah? Good? This stuff all is what we just got done doing. So cosecant is 1 over sine, or I just flip it, right? Whatever the sine value is, I flip it to get cosecant, okay? Whatever sine, or whatever cosecant is, I flip it to get sine. That's what these are. These are called reciprocal. Write this down. These are called reciprocal identities. I-D-E-N-T-I-T-I-E-S. Reciprocal identities. I know you guys can't see this on the video, but if you have a pink sheet in front of you, do you see the very, very top left box underneath of your unit circle? The very top, you have your unit circle, whatever, your unit circle is here, and then you have like a bunch of boxes below. In the top left box are the reciprocal identities. Okay, you have them. You get to use this on every test going here forward until we're done with all the trig stuff, right? So you have all the reciprocal identities. This can help you if you're like, oh crap, which one does sine go with? Hey, guess what? Reciprocal identities. He goes with cosecant. Got it? Okay, so there he is. Make sense? We're going to go through what all those identities mean, like going forward here, okay? Woo! Reciprocal and quotient identities. Okay, this is not too bad. Find the other trig functions. So they're giving me these 2 things, sine and cosine, and they want me to find the other trig functions. So I'm going to say sine of t. I'm going to space these out a little bit because some of these fractions are really ugly. Cosine of t, tangent of t. Sine goes with cosecant. Then we have secant. I'm spacing these out a little bit. And we have cotangent. Yes, I'm going to teach you how to rationalize right now. Okay? All right, sine, they tell me sine is 5/8. Like I didn't make that up. They gave that to me, right? Cosine is the square root of 39 over 8. Yeah? Okay, let's do his opposite. What's the opposite of 5/8? 8/5. He's good. He is good to go. Okay? They're giving me these numbers. These numbers are not numbers that are on your unit circle. But that doesn't mean that this is not an angle, right? T, this just means that whatever my angle T is does not live on the unit circle as a nice number. This might be, T might be, I don't know, 17 degrees. I have no idea, right? It's just not a nice number on the unit circle, okay? So whatever the sine value of that angle is 5/8. It's not on your unit circle because it's just not a nice number that we would put on your unit circle, right? Okay. All right, here's the kicker. Are you ready? This is where it gets a little bit harder. I did not do this the other day. If we take and flip this guy, he would be 8 over the square root of 39. But I want you guys to get in the habit of rationalizing these fractions, okay? We do not want to have square roots in the bottom. Have we talked about that before in a math class? Yes. Have we done it in this class? We did it maybe in Algebra 2, maybe a long time ago, okay? So the way that we get rid of square roots in the bottom is we multiply by the square root of 39 over the square root of 39, yeah? Okay? And so what ends up happening is the square root of 39 times the square root of 39 on the bottom this is like the square root of 39 squared. And what happens to the square root of 39 squared? It's just 39, right? If you take the square root of something times itself, it just pops out, right? Okay? On the top, it's just 8 square roots of 39, okay? Now, here's why I can get away with doing this. This is the very important part. What I'm doing is I'm taking this fraction right here and I'm multiplying by the square root of 39 over the square root of 39. This guy right here reduces to 1, right? So I'm just taking this number times 1, which means I'm not changing its value. I'm just changing what it looks like. I'm not like making crap up here, right? I'm just changing what it looks like. Make sense? Okay? So this is going to be the better form to write them in. So I want you to rationalize them as we go through. You will get to the point where if you can't already, you can rationalize these in your head, right? It's pretty easy to rationalize in your head. Okay, let's go to tangent. We have to do sine divided by cosine, right? Did you guys find my poster? Singerine over cosgerine equals tangerine. Sink divided by cosk equals tank. Siner over cosner equals tanner, right? Okay, it's right there for you. I'm not going to take it down for a test. It's there. We take sine, which is 5/8, and we divide by the square root of 39 over 8. Okay, and how do I do that? No, you don't. No, you don't. Because then your calculator is going to spit it out as a decimal, and I'm going to count it wrong. 100%. Always. You flip it. We're going to keep flip, flip. So we multiply by what? 8 over the square root of 39, right? Okay, then what happens? The 8s are gone, right? They will reduce. So tangent is 5 over the square root of 39. Do you see where we get that number from? Stop me if you don't. But he's not rationalized. So if I multiply it by the square root of 39 over the square root of 39, the bottom number will just be 39, but the top number will be 5 square roots of 39. Do you see that? Okay? All right. Are you ready for cotangent? Okay? Here's a little hint for you. Are you ready for this? Tangent. We had originally 5 over the square root of 39, and then we rationalized him like this. When you go and do cotangent, do not use this number. Use the original number. Otherwise, when you use this number, you're going to have to rationalize again. Does that make sense? Okay? So use the original number before you rationalized and flip this guy. If you flip this guy, what does he become? Square root of 39 over 5. I don't have to rationalize anymore. Yeah? Okay? So don't flip this guy around. He's ugly. Flip the original guy around. Okay? Make sense? That's what cotangent is. And you don't have to rationalize cotangent because the square root's on the top. Make sense? Yeah? These are ugly numbers, but this is just part of it, okay? All right, good? Okay. Let's do like a little bit more and then we'll stop. A little bit more and then we'll stop. Maybe we'll do the next, like example 5, example 6, and then we'll stop, okay? All right, the next thing is something called a Pythagorean identity, okay? Pythagorean identity. Circle those words right there. Pythagorean identity on your little box, okay? If you look on your unit circle, the top left box at the bottom was reciprocals. Look at the one right below that. Pythagorean identities. Okay, here's how these work out. Check this out. The unit circle. Up at the very top, yesterday I talked about the equation of the unit circle. Do you remember equations of circles was like x minus h squared? You don't write this down, please. Y minus k squared equals r squared, right? If the unit circle is centered at 0, 0, and the radius is 1, he has the equation x squared plus y squared equals 1. That's what this circle is as an equation, yeah? X squared plus y squared equals 1. Okay, hold on. Sine and cosine. In terms of sine and cosine, what is the x coordinate?
Of what?
In terms of sine and cosine, what's the x coordinate? X is cosine, right? In terms of x and y, or sine and cosine, y is the cosine, or excuse me, y is the sine value, yeah? So another way of writing the unit circle is saying cosine squared plus sine squared equals 1. Hey, check it out. Cosine squared plus sine squared equals 1, yeah? This is a Pythagorean identity. Okay, good? Yes? Okay, so here's another thing that we could do. Let's say we have, I don't want to get to that. I don't want to get to that yet. Okay, sine squared plus cosine squared equals 1. Not only that, but you have, I don't have these bottom two memorized. Tangent squared plus 1 equals secant squared. 1 plus cotangent squared equals cosecant squared. These two I don't have memorized. That's why I put it on the unit circle for you. You should probably memorize sine squared plus cosine squared equals 1. Also, he's a poster. You see him? Have you seen him? Right here, you can kind of not see him very well. I wish I were a sine squared and you were a cosine squared, so together we could be 1. Ha! No?
That's good.
Ah, it's cute. That's good. Right there. That's right there. That's Valentine's Day. I know, right? So he's right up there. Okay, so that's how you can remember. Sine squared plus cosine squared equals 1. I don't have these two memorized, but we will use them from time to time. Okay, here we go. Ready, set. Example 5. Example 5. Let's do this stuff. Okay, using the Pythagorean identity. Whew. Okay, they tell me 2 pieces of information. Tangent is 12 over 5. Okay. They also say this thing right here. What the heck? Pi to 3 pi over 2. What does that mean? So that tells me what? 180 and 270. So that tells me that we are in the
Third quadrant.
third quadrant. Yeah, we have got something going on in the third quadrant, right? Okay. So like here's what it looks like. Here's my angle. We're talking about an angle in the third quadrant if he lives between pi and 3 pi over 2. Pi is here, 3 pi over 2 is here. So this basically just tells me, hey, we're in the third quadrant. That's all that means. Yeah?
That's good.
That's good. That's very good. Okay? All right. They want me to find the value of secant. I'm not going to use a Pythagorean identity to do this. You can, but I don't want to. But I don't want to. Okay. All right, here's the deal. We're gonna go off script here. I'm gonna show you kinda. I'm gonna show you using SOHCAHTOA how this works, because that's something you're familiar with. Who loves SOHCAHTOA?
No. It's not that bad.
You don't love it?
No.
Okay, SOHCAHTOA. I love SOHCAHTOA. SOHCAHTOA is my friend. Okay? So there he is. Do you guys remember what SOHCAHTOA means? Opposite, hypotenuse, adjacent, that type of thing? Yeah?
Right. Fine.
Okay. So here's what we're going to do. I'm going to take this little side right here, because that's the one that we're talking about, and I'm going to make him into a triangle. We never connect him back that way. We always connect him back this way to make a right triangle out of him. We always connect him, and we make bow ties, not hourglasses. Did you hear what I just said?
Yep.
Let me tell you what I mean when I say...
A while ago.
Did I say that a while ago? Bow ties, not hourglasses?
Yeah.
Okay, here's what I mean when I say bow ties, not hourglasses. If I have a dot here, or a dot here, or a dot here, or a dot here, and I'm connecting them. So, like, here's where my angles live. Got it? Okay? This guy, we're going to connect him down. If he lives over here, we're going to connect him down. If he lives over here, we're going to connect him up. If he lives over here, we're going to connect him up in order to make triangles like this out of him. We do not do this. Dot, 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 line, 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 line. We don't make hourglasses. We don't connect him that way. No. We make bow ties and not hourglasses, yeah?
We like the X.
We like the bow ties. Okay, so I'm going to make this into a triangle. Here's how this works. The tangent of my angle is 12 over 5. Okay, I'm going to make this real easy for you. Tangent of my angle, do they call it T?
Oh, it's all coming together. That was just commentary.
Okay.
It is.
Tangent is 12 over 5. Tangent means which one? SOHCAHTOA. Tangent is opposite over adjacent. The opposite side is 12. The adjacent side is 5. Okay, so where does my angle live, by the way? T? T lives right there. T lives right there in the corner. Okay, so the opposite side is 12. The adjacent side is 5. Yeah? Yeah? Now, real quick.
I should probably be writing this down.
You should probably be writing this down. Okay?
O, A,
Okay, do you see where I get those numbers from? 12, 5, opposite, adjacent. Now, here's the only big problem that you do not see.
13.
Is 5, 12, 13. You're right. Okay? Now, here's the only big problem that you do not see, but the fact that we are in the third quadrant makes a difference.
Negative.
5 is negative because we're going this direction. We're going to the left, right? 12 is negative because we're going down. 13 is not negative. 13 is always positive. Okay, the hypotenuse is always positive. So the fact that they tell me I'm in the third quadrant means, because this would be negative 12 over negative 5, which is also reduces to 12 over 5, right? Okay, so the two negatives cancel, which means that you don't know they're there, but since we're in the third quadrant, we have to put them back in.
I don't understand.
Why?
You don't understand that?
If it's not like...
Yeah, because why is it? Oh, wait, because it's negative over negative. So it's
Yeah, so it's a negative over, like negative 12 over negative 5 is the same thing as positive 12 over positive 5, but they're only going to write it with the positives.
That's cool and all, but like...
That's cool and all. Okay. All right, they want us to find, what are we even trying to find? We're trying to find the value of secant. Okay, which one does
That's all we need to
secant,
find?
which one does secant go with? Cosine. So if cosine is the adjacent over hypotenuse, which side is the adjacent side?
5 over 13.
The hypotenuse side is 13. Here's where T lives. T is here. The side that's adjacent to him is -5. The side that's hypotenuse is 13. So if we're trying to find secant, secant will be 13 over -5. There it is.
This is stupid.
Mm-hmm.
What are we solving? Like,
Yeah, that was a horrible process for like.
That was a
one
horrible
little
process. Okay, now,
thing.
shall I show you how they wanted you to do it?
No.
This doesn't make sense to me in my mind, but this is how, it's probably faster and easier. Tangent is 12 over 5, and we're trying to find secant. Do I have a Pythagorean identity that has tangent and secant?
Yeah.
You betcha I do, right here. Right here. Tangent squared plus 1 equals secant squared. So tangent squared plus 1 equals secant squared. Here we go.
Can we do that on here?
You betcha you, yeah, probably. I think.
Tangent squared.
What is, no. What is tangent? What was the value of tangent? Did they tell you? 12 over 5? 12 over 5 squared plus 1 equals secant squared.
Oh
Yeah?
my gosh. You wait.
12 over 5 squared is 144 over 25. Yeah? Plus 1 equals secant squared. Okay?
Oh,
Yeah?
we have to take this
Okay,
square.
if I find a common denominator, this will be 25 over 25. That's what 1 is, right? If I add these two together, what's 144 plus 25? 169
2.6.
over 25. That's equal to secant squared. Yeah? Now, how do I get just secant instead of secant squared? You take the square root, of course. What's the square root of 169?
13.
13. What's the square root of 25? Except,
They
That's
could
not
both
the
be
answer.
plus or minus, but-
it could be plus or minus, but which one is it? It is minus because we're in the third quadrant.
That's worse.
That's horrible. You think that's worse?
Yeah, I think that's worse.
I think
That
so, too.
makes less sense.
I think so too. But it works out, checks out. Like all of it fits together. All of these equations and everything fit together. Okay? That's a lot.
I think we're done.
You think we're done? You're checked out? Your brain is fried? Okay. Okay. We'll stop.
Like, what
'Kay.
purpose does this have?
If you have not already, go through and get up through 16. Probably further than that, but if you have not already done so, get all the way up through 16.
I don't know.
Well, what the heck are 6 and 10?
I don't know. 2, 4, 6, 10, I think are vocabulary. Like fill in the blank stuff. Yeah.
yeah, 65 is kind of hard.
Okay. All right, I'm going to stop the video and then I can discuss.